I am Davood Rafiei, and I'm going to give you an overview of our work on discovering and integrating tabular data. Let's start with this scenario. Consider a business intelligence officer who has to collect data from different sources in order to build profiles of companies, for example, for loan applications. One source in this case has addresses and the companies that own those addresses. Another source has assessments done, for example, by the city. And the third source has stock valuation. And what we want to do is that we want to put these pieces together so that, for example, a loan officer can use. Some of the challenges here is that, one, we need to find these sources that has the desired information. Second, we need to put the pieces together despite formatting differences. Okay, so the data changes in this case, like in these source of data changes. So this is not a one-time process. We need to do this process a number of times. So we need some mechanism. We need tools for doing this. One of those tools that we have built is Vertical, which has operators for searching tables based on keyword and also based on tables. It has operations for expanding a table. For example, you have found some information, but you want to expand it. And it also has some functions for transforming tables. Okay, so let's look at this table expansion. So for example, I have some information about companies, but I want to add additional information. For example, I want to know this company owns this property since when. Okay, so this is one type of operation. Another type of, well, expansion is that we have some rows and we want to add more rows. And I can also have missing values that I want to fill. Okay. And sometimes I have data from different sources and I want to put them together, but the formatting, they don't follow the same formatting. Okay. So I need some mapping or transformations to map one formatting into another formatting, or I need some transformations. Okay. Some of the challenges here and progress made, there is a huge space of the space of possible transformation is huge. We have many transformations, and each transformation has a number of parameters. And what we need to do is that we need to search that space to find the desirable transformations. One question is that what transformations are desirable? We want to find those transformations that are general. They cover a large number of rows. Ideally, we want to find one transformation that transforms the whole table. Okay. There is some work on reducing the search space. Auto-join is one, which works by sampling. And CST is our work, which is based on finding common strings in source and target and using that as clues to find transformations. And we show that CST improves, in terms of efficiency, CST is a few orders of magnitude faster than AutoJoin. Okay. More recently, we have looked at transformer models for doing this mapping, because these models are good at understanding the language and they're also good at generating text. And in this particular case, we start with a pre-trained model, which in our case was IT5, and then we fine-tune it using some data. In our case, data was synthetic data. And then we do prediction by following this decomposition and aggregation model, where we decompose the problem into smaller pieces. We do prediction for each piece, and then we put together the pieces. And in this case, for example, we have these source target pairs, and I have these sources. So what I want is that I want to find target for them. Okay. And we show that this model, even though it is trained on synthetic data, it does really well even on real data, and it does better than state of the art. Okay. To conclude, we have large collections of data out there. The structure is either not known or it doesn't have the structure. We need to integrate the data from these different sources, despite their formatting differences, and we need to query them. We want interoperability of operations. Large language models help, but they don't solve the problem. So we need to do more work on top of them. That's it. Thank you.